Alexa, what day is today?
Today is Tuesday, April 24th.
What time is it?
The time is 8:21 a.m.
Turn on light one. Hello, Linton here again. Today we're going to be talking about methylation. Well, no, not really. We'll be talking about a specific occasion for methylation and how it works, how it relates to our project. Um, okay, we've done work with flies and show that kinship within the limits of science does indeed change kinship, does indeed change fertility in these insects, and that change is so rapid and cyclic it can't be due to DNA mutations, but it must be brought about by an epigenetic mechanism. Now, there are a lot of epigenetic processes. The easiest one to get at is to go for the fact that um, methyl groups on DNA can alter the function of the genes. All right. Usually, a methyl group. You know what a methyl group is a methane is a gas with carbon and some all the open bonds, the four of them on carbon, have a hydrogen attached to them, and that's methane. And if you pull off a hydrogen, you have an open bond, hook that up to something else. And it's a methyl whatever, like if it's chlorine, that's methyl chloride. Or if it's a polar bear, that's methyl polar bear. I don't think that one's been done. Um, uh, so I made a cocktail reported by Dr. Watterson in diet-induced hypermethylation at agouti variable yellow is not inherited transgenerationally through the female. All right. Um, what is agouti variable? That's a that's a um, that's a gene that he's attaching methyl groups to, and so he published his methods, including what he used to induce it to put methyl groups onto his DNA, and so this was my attempt here to uh, use the same formula. So I made up the same formula as he did. Um, it wasn't terribly satisfactory because in my hands, the everything doesn't dissolve. Um, so you had to do a lot of stirring. Um, uh, Full strength, I'm going to call 100%, and did dilutions from there. In a little side experiment, I found that flies could tolerate the 40% dilution, but not much more. So figured we'd start at 40%. Um, Watterson probably worked up to a level where they were saturated. That was his plan. And that's what 100% can do for you. He probably approached that slowly. A little hand waving is why that might be necessary. Um, well, why I think it would be necessary. We started at 40% and go down totally at sea about what kind of concentration to use. Did a baseline. We remember we had damped oscillation with these flies. These same flies kept counting for a entire cycle um, of damped oscillation, year or two, um, and then gave them a 40% dilution, which means in the final food, um, the the food and water, um, it was a 40% dilution of what he had used. We counted every day, 2 windows, added up for 2 weeks. Here's the schedule by which the look, if we'd started real low and worked up, we might have got to the point where they all died out. And we said, okay, what is that toxic effect or what? But we started at 40% there and worked down. We knew they could tolerate 40%, so we worked down, and if something strange happened, we'd say, well, we're not just poisoning it with too much of this cocktail. So there's how we did it, and here is our result. All right, so the yellow line up top is the highest 2-week count. The black line on the bottom is the lowest, and the red line in the middle, that's the average. The long 2-year baseline we took gave us a very high highest one and a low lowest one, all right, and gave us an average. So here comes the so start the system rolling. We're going to give them slowly less and less of the cocktail. And as you see, instead of damped oscillation, we get something weird. They keep going up and down and up and down. Now, a couple things going on. We're changing the concentration of the methylating cocktail that Dr. Watterson described, and population size is changing, and generations are going by. But, well, whatever this is not damped oscillation. Up and down very aggressively. That's complex behavior. Look, we know there is a post-zygotic process involved because that's the only way to get damped oscillation. But I have off and on over the years played around with pure post-zygotic process, and you don't get complex behavior. This is complex behavior. So it's both pre-zygotic and post-zygotic mechanisms. All we've done is add methyl groups to the DNA. So we now know more than we set out to find out. You can see where we started the baseline and work our way down to 5%. So yeah, there's an effect of methylation. I gave a highest and lowest instead of a 90% confidence interval because we got no justification for saying this is going to follow a normal distribution, and that ordinary statistical analysis based on a normal statistical distribution of the values wouldn't really mean anything to me. So taking the highest and lowest, at least I know what I've said, and you can tell that the average, the highest and lowest, they go up and down together. So we're not looking at noise. Okay, we might have a toxic effect from the supplements. Might have some. I mean, look at how the average number of counts, the population declines after the where is it? Where are we here? Population goes down when you hit them with the methylating stuff. So yeah, there could be a toxic effect. Remember that 40% we were pushing it. That was about the highest they could survive. They're still flourishing, of course. All right, so there might be a toxic effect. There might be a nutritional effect. Okay, at some concentration, maybe you'd get a boost in your in your population because you got all these nifty supplements. Remember, there was a bunch of things in there, and we know this post-zygotic process. Dilutions are changing, but even throwing all those things at it, that's just too much variation. Systematic variation. That's not noise because the highest goes up and the lowest goes down. Um, and yeah, they stick pretty well in parallel. Okay, the spread between, say, that value, so that's the average and that's the spread, total spread. All right, that's probably come to some kind of statistical variation. The width from the highest to the lowest is probably statistical, and it just stochastic, just random noise, and I can't tell you whether that's noise, whether it's fluctuation in the population, or just because of our limited way of estimating the numbers. Obviously, not counting all the flies, just those that appear in the window. Okay, someone come up with a better explanation. I am all ears. But the weight of the evidence so far is that there is at least one pre-zygotic mechanism and at least one post-zygotic mechanism, and both of them are mediated by some process involving methylation. So that's what we found. Obviously, it took years. You can look at the dates here, and that would be 2010 to 2015. It's been 5 years or so to do it. So I doubt you're going to want to try to do it as a high school project, because if it's taken you 5 years to get through high school, you probably have better things to do with your time than play with this. But weight of the evidence is, yep, pre and post zygotic, and yep, it's mediated by methylation. And that's good, because of all those epigenetic mechanisms, the methylation things, they don't have any comprehension of it all the microRNAs and adding ethyl groups rather than methyl groups, 2 carbons. They leave me baffled. But oh yeah, I can go down and buy the store and buy those chemicals he talks about, stirring them up and say, I'm adding methyl groups. So thank you very much. We will come back another time. Alexa, turn off lamp 1.